Hello, I hope the audio voice is there. Cool. Okay, so today's agenda is two problems related to stack. So I'll start with a largest rectangle and a histogram. Okay, so basically largest rectangle in a histogram. So we are given bars like this and two and then three, right? Two, one, five, six, two, three. Now return the largest rectangle. So basically this will be same and then this will be minimum, right? So like here this thing. So 5 into 2, 10 is the answer here, right? Now one way is to do a brute force like you take this each element, right? That will be like n square solution. Basically where I'm considering starting from 2 all the possibilities where 2 can be, right? But what is the best possible answer for 5 here that we have, right? So for 5, when will 5 be contributing? So 5 will only be contributing until it sees an element that is less than this. So till here, here it will be contributing just till it itself. So this is where 5 will be and 6 just here because each number will be contributing, right? So width, we can fix the height in each. So I fixed height at 2. Now I want to find how much left I can go, how much right I can go. Fix the length as 1. Now that is where concept of monotonic stack comes into picture. Right. Now what does monotonic stack say is that it can help you find uh, the next greater element. So basically 2 1 5 6 2 3. Basically we found the next smaller element, right? Next smaller element to right and next smaller element to left. So that is our aim is right now. Next smaller element to 3 is -1, to 2 is -1, to 6 is 2, to 5 is 2, to 1 is -1, to 2 is 1, right? Now how we are doing this? So when let's say we put 3 into the stack, right? Now if a smaller element comes, so this is basically useless, right? So our aim is to keep the monotonic stack in a in increasing manner. So it should be like 1, 2, 3. If 6 comes here, that's of no use, right? Because next smaller. Okay, so if 8 is here, right? Now for that this 6 also might be useful, right? But we want to keep, so if 1 came in, right? So this 2 is not of any use. 3 is not of any use. So we want to keep it in a decreasing order. So 3 came, it was empty, you put it there. Now 2 came. Is there any chance that 3 will come? No, right? So you just put 2. 6 came in. Is there any chance that 2 will come? Yes, probably. 5 came in. Is there any chance that 6 will ever come? back. So you already have a 5, right? Is there any chance that 6 will ever come? No. So that is how. So you keep your monotonic stack in a decreasing manner, right? Then you do that both the ways. If there is no element, you just say it as the next element. You can say this. This could be. So we need to get the index right. 5. This could be 6. So let's say for 3 it is right. 3. All the elements on left are let's say less. So for 3 it will be 3. And then what is the value on its right? The next smaller index or next smaller. We can do -1 later, right? So uh, smallest element on our right, SMR, and now I want to first collect smallest element on left. I want to first go with right. If stack is empty, then SMR. If it is not empty, while stack is not empty, and see same also will work, right? Keep on popping it. So if nums dot I, if it is greater than, right? If it is less than, so once you have done this, right? So for int I is equal to, so you have got your left. Now you're going to do the same thing for shell. If it is empty, then left mode will be -1 because there is no element. And then when you will do it is, so for example, let's say I'm talking about this 2, right? So you need its leftmost. So that is -1, right? So what we will basically do is we'll take and let's say talk about its and that is let's say 1, right? So it will be 1, this minus that plus 1 minus 1. So that will be basically 1, right? So SMR of I, SML, smallest element left, will be. So here these are index basically, right? These are not the elements actually. These are the index. Element it's itself only. Now, now here just dot. Here what I'm going to do is heights of I, right? That is the current height, and then SMLR minus SMLI plus 1. Okay, we'll see what is the system.out.println. Okay, it is all -1, is it? Okay. Oh, never push to stack, right? So this always goes in. Whether it is okay, so basically what we have basically done here is that you start from n-1 I greater than 0, right? So we are printing SM right first, right? SM right is 6 because there is no element that is that, right? So that is basically 6. Index of element. Then I think all of these correct. And basically for this it should be 6, 6 smaller, then again 6. For this 6 should be 4. That is correct. For this again should be 4. For 1 everything is greater, it should be again 6. For okay, so basically what is happening is it should not be -1, I think it should be 0. So 6. Oh, okay, this is supposed to be -1, right? This now could be -1. Or again, I think that, yeah, this is supposed to be 0. Yep. So that is how it goes, guys. Hmm. Okay, let's solve this question. So there are n. Okay, so there are n cars that are given miles away from starting mile and traveling to reach the mile target. You are given two integer positions. So basically, you are given a speed and a position, right? So position and speed, right? Now you have 10, 8, 0, 5, 3. Then you have 2, 4, 1, 1, 3. Now target is 12. So you are given two integer array positions, a car, but it can catch up and then travel to next. Okay. Okay. So basically, if position. So first of all, you need to know the positions of each car, right? So for example, let me sort it using position. So it will be 0, your speed is 1, and then you're at 3, your speed is 3, and then you are at 5, your speed is 1, then you are at 8, your speed is 4, then you are at 10, your speed is 2, and we have to reach 12, basically, right? That's the idea. Now 0 will go, so that is the thing, right? Now think of it like that 0, how much time it will take? It will take 10 seconds, but there could be a case that if there is no car behind it, right, then no one will ever cross it. So, for example, 10 will reach itself to each other. There is no car driving next to each other, right? Hmm. If zero's speed is 1, if it will ever cut that, that's the thing, right? If it will ever cut it, if then it will get the speed of the smallest car. Hmm. So you have 0, 3, 5, 8, 10. Right? So these are the distances 1, 3, 4, 2. These are the speeds. If I sort them according to the speed or the distance that one, so this will travel one distance, this will travel 3. The point to think here is, so so basically how much time this takes, right? This needs 1 second, this needs 2 seconds because 12, right? So 2. This also need 1 second, This needs 7 seconds. So we'll write it a new line. This needs 1 second. This needs 1 second. This needs 7 seconds. This needs 9. This needs 3 seconds. And this needs 12 seconds, right? This is the time they need. Time needed. Now, is there any car which is coming from behind but needs less time? Because if there is, then it will accordingly join to the other car. Here, this one, this doesn't need, this doesn't need, this needs more time. Now, this is there, right? Now, this is coming from behind, but it needs, okay, even if they both reach at same time, then also they will become a fleet, is it? So they both, if they both reaches at same time, and if the element has, if this is more, like in this scenario, it is same, then it is good. If it is less, then it will merge. If it is more, you can't do anything. So basically, if you sort it based on this, and then you put it in a stack, then you say that if it is same, it becomes one fleet, and then you put 7. Now this is less. So basically, any car, this takes 3 time, right? This is less than this. So basically, this will merge into this. So you basically, this becomes a new fleet again. So remains 7. The fleet increases. When 12 comes, 12, basically you can pop that out. So basic idea is that if there is a car that starts from behind but has more speed, right, or same speed, then it is going to merge or it is going to reach at the same time. then it is definitely going to merge. So this is going to merge, and if it is going to merge, then it is going to merge in a same, right? Let's say this car had a speed of 12. So this will also reach in one time, but it won't be able to cross any of the given cars, right? Hmm. So if the next element reaches in more time, let's say here 7, then you don't worry, you just put it into the stack because that is going on its own pace. If after that there is an element that says that okay, I can reach in less time, right? Then that means after that there is an element that says that okay, I can reach in less time. That means that you need to merge that element into the stack. It's true. So position is 0 to 4. Position is 0 to 4 and speed is 4 to 1. So destination is 100. So this is like 96. We'll take 96 and this is 98. It will take 49. This is like 100, but it will take 20, right? So this is 96, right? It is on its stack is empty, so you just put this into the stack. Now this comes in, it says that okay, I am coming from behind, but I can reach it before that, right? So this basically goes into the stack 96. This you don't need at all. This goes away because it is smaller than that. So your 96 stays. Same with 20. So number of elements in a stack is the fleet size, right? Because all others are merging. Now in 1, 3, 7, 1, 1, what happened? 1 came in, you put it into the stack, this comes in. It says that okay, I can, so you pop that out. It's the same stack. Now 7 came in, right? Now 7 is greater than 1. Basically, it will reach after us, so you put it there, right? That's a new fleet. Now 3 comes in. 3 is less than, so you don't need it, right? Then after that 12 comes in. So it is 12, 7, 1. I think yeah, that's the correct thing. So you keep your stack in decreasing manner only. So now first of all arrays dot sort. You can now you can we can just create a new int cars. You can keep it 3 only then. Let speed also come there. that is position of I, then speed of I. One is number, like the time it will take, right? Now that will be like target minus speed. You can make it double. Let's go with int first. By speed, right? Mhm. What you will do is you'll sort it based on the position. Then you will start from last. Now if while stack is not empty, or and cars of I, comma its reaching time. If it is less than equal to stack dot peak, then you basically, so 3, right? 3 is less than. If it is equal also, then also you continue kind of, you don't need this. This is combined into whatever is in the right. Now if now whenever you will come here, so you'll just post it, right? Fine. This should work. Mhm. Okay, okay, okay. If there is no double thing, it will work fine. So let's see. So you have 6, 8 positions are good. Your speed is 3, 2, and target is 10. So this is saying that I will take only need to traverse 1 minute, and this is also saying that I will take 1 minute, right? Which is wrong. It will take more than that. So it will never come here. It will never be less. So that's by right. So you basically need so that see hours are basically you can do like this. What I'm doing is I did target minus position, which was 4, and I did plus 3 to 6. So it will by 2 because we need hourly data, right? Is it? But it can catch per hour. Right, hourly data should be fine. Otherwise, I'll have to make it double. Yeah, I think the speed of every car is 4. No one will chase anyone. But why this should work, right? So we have like 3, 4, 5, 6, 7, 8, and each car has 4, 4, 4, 4, 4, 4 speed, and they have to reach 10. So this will be 2 plus 3, 5. It will take 1 minute, right? 1. This also will take 1 minute, but that will overflow, is it? Hmm. If they don't match, here each will be same. Oof, 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 oof. Mhm. How do I see them? Maybe make it double then. What will happen if I make it double, 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 double? Okay. And I know to like this. Mhm, 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 mhm. Oh, so clean. Mhm. Yeah, it will take more time, right? There we were rationalizing it. Yep. Yes. Cool. Now, how much time do I have? I have close to 35 minutes left. Okay. We'll try to solve weekly contest then.